Hello everyone. Today I'll be talking about how artificial intelligence can be sustainably used to detect algae in the ecosystem. The objectives of this paper are to integrate microalgae detection and harvesting using artificial intelligence. This includes modeling techniques based on mathematical and statistical based models that can provide vital information and provide accurate prediction rates. This can reduce the rate of eutrophication and utilize more algae towards the cultivation process, which brings us to our next point. The integration can also reduce the production costing of microalgae. This is done with machine learning algorithms used along with sensors installed along at photobioreactors. This predict and proposes models to increase the yield of biomass production. Microalgae can grow in extreme environments. It could also be produced on agricultural and non-agricultural lands. It makes use of the wastewaters, municipal sewage, and also industrial effluents. Microalgae also has this usage. If cultivated, they can be used on the production of biofuels, liquid, bioethanol, diesel, vegetable oil. The industrial scale has also expanded over the past 20 years as they move towards different products and different technology of line. So, what causes eutrophication? Excess plant and algal growth due to the increased availability of more growth factors, in this case, high nutrient factors from agricultural, residential, and urban waste. The detriments of eutrophication ecological-wise include toxic algal bloom, dead zones, and decrease in water transparency. Scattered penetration of light through the water surfaces inhibits the growth of submerged aquatic plants, which can disrupt the food cycle. Socioeconomic impacts also arise, as the enrichment of nutrients to an ecosystem can result in massive growth of microalgae. The existing of such dense algal growth already there can inhibit or prevent access to waterways. This means that microalgae can be a rich source of carbon compounds which can be utilized in biofuels, health supplements, pharmaceuticals, and even cosmetics. They have also application in wastewater treatment and atmospheric carbon dioxide mitigation. Microalgae can produce a wide range of bioproducts including polysaccharides, lipids, pigments, proteins, vitamins, and even antioxidants. The industry cultivation of microalgae to produce biofuels and bioproducts has increased dramatically over the last few decades. Algae are produced in quantity and sold as food and nutrient supplements, while pond systems are shallow ponds that allow up to maximum height of 70 cm where microalgae are cultivated using water paddle for mixing nutrients with water. Despite open ponds allowing mass cultivation, low costing, and easy to operate, they increase contamination rate, leading to unwanted organism growth in ponds, which also in hindsight affects the biomass concentration. That's because only a limited range of microalgal species can operate under extreme conditions with high pH or salinity. Photobioreactors are more sustainable in production as the control of algal growth allows them to increase productivity of algal biomass. Contamination with other algal species are also avoided as PBR limits the direct change of gas and contaminants between the culture and the atmosphere. However, with high operating and maintenance costs and varying biomass concentration from 20 to 100 grams of dry matter of algae biomass per day, this is where artificial intelligence can come in to modify or control model parameters. There are many factors determining the microalgae cultivation yield rate. It comes down to concentration and nutrient quality, water supply, pH levels, salinity, and other parameters. These parameters can be used as data collection in the artificial algorithm model, which will be employed. In order to successfully integrate AI within microalgae cultivation, we will need to have advanced sensor technologies, multiple sensing for physical and biological parameters to continuously real-time operate and generate biomass production forecasts. Algorithms and networks have different network processing and hence a different network forecasting. Forecasting results can vary and hence parameters that are taken under consideration to ensure the yield of microalgae is successful should be monitored closely. In succession of doing so, early detection of algae accumulation can be detected. Sustainability of AI technology can be proven worthwhile in the long run if socio-economic patterns such as cultivation of microalgae as a biofuel can develop into serious long-term potential investments. They can be used for power production requirements and to communities surrounding them. Increasing usage in the biofuel production will also mean lesser use of fossil fuels as dead zones are slowly starting to clear out and pollution in rivers and also coastal regions are also beginning to subside.